Hello everyone, welcome back to my channel. Today we are deep diving into what is easily one of the most important upgrades in Ethereum history, the Fusaka upgrade. This upgrade fundamentally changes how Ethereum handles data availability, how L2 scales, how the entire rollups ecosystem evolves. If Denkan in 2024 gave us the proto dark shading, Fusaka turns the early design into the something truly scalable. This video is those upgrade you need to understand not just as a developer but as a builder and investor too. So our topic is Ethereum Fusaka upgrade. So the first is why Fusaka? What problem Ethereum is facing? So we have to introduce the Fusaka. So let's start with the root cause. Ethereum wasn't failing, but it was hitting a ceiling, and the ceiling was data availability. Here's the what happens. L2 layer 2 adoptions absolutely exploded. Rollups like Arbitrum, Optimism, uh, Base, Zk they all started posting more and more blob data on Ethereum. But the Ethereum couldn't keep up with the demand. Every validator had to download a full blob data, even though most of the data wasn't directly relevant to their duties. The mid bandwidth was skyrocketing, and storage was increasing, and throughput for the L2 was bottlenecked. So we had these strange situations. Their layer 2 were scaling, but Ethereum layer 1 wasn't scaling with them. Blob fees became unstable, the DA markets broke down, and the Ethereum ability to act as a relatable settlement layer 1 layer was being stressed. So Fusaka comes in to solve the foundational bottleneck. So here's the with the Fusaka, like before the Fusaka, the gas markets become unstable. Node resources usage kept growing, limited throughput for the massive L2s. So here's the one diagram. We can see that in that first is a user layer, user transaction by the L2 layer 2 rollups, and that all data for the successful transaction by the proving and security they goes by to the L1 layer 1, but every nodes and stores full blobs. So they can't transaction do speed. L2 gives the speed, but because of the L1 limitations, L2 also not performing better. So there is the Fusaka needed, and so that we introduce the Fusaka. So the second one is where Fusaka fits in the Ethereum long-term plan. This upgrade is not a random. Fusaka sits perfectly in the Ethereum long-term roadmap. Think of it like roadmap as a multiple phases. The first phase in 2022, the merge. In that phase, we do the POS transaction. Like is the most important that time is POS transition. POS means before the 22, Ethereum is working on the POW, proof of work, but in 2022 that is a merge and that happened with the proof of stake. So that is the most important for that time. And then after 2023 and 24, the surge is came, and there is a roll-up scaling, proto-dark shading, and blob transaction is the most important priority. And after, like in this year, we are introduced with the Fusaka, is the PeerDAS, blob parameters, only forks, gas limit, and DOS hardening. And the big after the roadmap, the future roadmap of future enhancement is the shared expansion, state expiry, further scaling is like in the next roadmap of Ethereum. So in the diagram, like a roadmap shows like that way. In the merge phase in 2022 is a POS foundation. POS foundation is happened, proof of stake foundation happened in the Ethereum. In the surge phase, the scaling through with the roll-ups, blobs introduced for the scaling of Ethereum. Then the Fusaka is the true data availability and sampling. The future upgrades of Ethereum in 2026 will be full sharding, dark shading, execution parallelizations. Fusaka is basically the bridge between the proto-dark shading and real sharding. It's the movement. Ethereum shift from the theory to the real DA scalability. Then the next is came Fusaka. Fusaka is not a one feature, it's a bundle of deep protocol upgrades. It's not introduced for the one feature only. Sometimes people thinks like a Fusaka is equal to PeerDAS. So not true that. Fusaka is coordinated set of major upgrades like a PeerDAS. PeerDAS is related with the EIP 7594, and PeerDAS means peer data availability sampling. Then the blob market corrections and rebalancing. Then the block gas and the capacity expansion, like block gas limit increases. node and storage performance upgrade, node efficiency and storage reductions. So this protocol wide restructuring not for the simple enhancement but it's a multiple improvements and coordinations. Then the next is the DA problem. DA means the like data availability problem. The before Fusaka, what are the DA problems happened? Before Fusaka, data availability was core limiter. Like why data availability was Ethereum scaling bottleneck. So here's how that worked. L2's publish large data for large data blobs to L1. Like L2 publish a huge blob data to Ethereum. Every single validator had to download full blobs. That is a huge bandwidth and the storage is also increasing. That means like a gigabytes of unnecessary bandwidth, high storage overloaded, then the slower validations happens and less decentralization because the only stronger mechanism could keep up. This was the Ethereum's biggest bottleneck. Here we can see in this diagram also full blob data how that works. The large blob data like 180 128 KB per blob. So 100% data, 100% data, 100% like this way. So one validated node download 100%. Then second also download that. So network retaliation is happen that they have to download whole data and that is not needed. They have to huge storage problem also. So every validator had to download full blob. There's huge storage they needed and huge bandwidth for that. So that is a DA problem happened before Fusaka. So that and the next coming is PeerDAS, peer data availability sampling. So we know this is the star of the Fusaka upgrade, peer data availability sampling, PeerDAS. Instead of downloading entire blobs, validator now download a tiny and random sample for the blob data. Here's the magic is happen. So the node sample tiny slices of the blob data and not the full blob. Security is maintained and the cryptographically also. Data sampling diagram, data availability sampling diagram, first we saw and understand. So here's the large blob data that 128 KB. The cell one is the random sample and sent to the this 2%. Like validator 1 download 5 to 10 cell, validator 2 or 3 like downloaded 5 to 10 cell and this also downloaded 10 cell, but they are giving the sample cell 2 cell 3 cell division is apply here and they send this random samples for them for the data validator sampling. And so validator also not have to download the whole data. They don't have to download the large blob data whole in there. So they know the sample and they validate and they confirm it. So here's the magic. What is the magic with the PeerDAS? It's a blobs are ensure encoded. So here's the magic happen. Like blobs ensures encoded and broken into the cells and validator request for the random cells. If even the part is missing, then reconstructions fail. The block is rejected. That means you get a security, decentralizations, and massive bandwidth reduction. It's one of the most elegant, powerful cryptographic tricks Ethereum has adopted. With this like a graph, we can convert this in this type of steps. How the PeerDAS ensures the data availability. Blob data is ensure encoded, data splits in the cell, validator full random cells. Pull the random cells if the blob is missing. Reconstruction is fail and block invalid. Security increases as more validator samples. Here like how the whole diagram shows original data and the ensures that all are encoded data and redundant data added. Then they divided into the different cell division and validator for the validator validate the random samples. So they all get a random samples and they downloaded the random samples and they verify that availability. All validators verify that data availability and the data available they go to block valid, then network secure and block invalid, then network alert. So like this way the PeerDAS availability working. This is the impact of switching the full download to sampling. Means the what changes after switching to sampling. Before that we download the whole data and now we downloaded the sample. So what are the difference happens? Let's look all the real metrics. So here's the metric like a validator bandwidth is before Fusaka is very high and now it's 8 times lower. Max blob capacity is limited before Fusaka and now the 8 times expansion. So we can blob capacity 8 times more. Rollup throughput is a capped, like it's full. We don't have to any space for that new rollups or new transactions and all of that. Then now that scales massively. Decentralization is declining and now that increased lighter nodes, because the lighter nodes that also increase. Storage overhead is high for that time and now dramatically reduced. It's so much reduced after Fusaka. This is the part of people underestimate. So with that, we can understand the more DA, the cheaper L2 fees, and after cheaper L2 fees, that become the more volume we can go for, and the higher throughput we can get, and the more ETH burn on L1. It's a simple cycle. It's a complete cycle of network growth. Blob fee market correction. After a proto dark shading, blob fees drop close to zero. That sound great for user, but terrible for the Ethereum sustainability. Rollups paid almost nothing, unsustainable. Like rollups paid almost nothing. L1 wasn't capture the value then. And Fusaka introduced new minimum blob reserve fee, restores healthy competitions and value capture for L1. So fee market or also collapsing. Fusaka fixes with the minimum blob reserve fee. This restores the healthy pricing and ensures the L2 contribute fairly to L1 security. Fusaka increases a block throughput dramatically. This is a simple but important. More blobs per block and the cheaper L2 transactions. There is before that this much transaction, the 1% like, and the after after this Fusaka, that's 8 times bigger. Like a capacity is very much increasing. So more blobs per block and the cheaper L2 transactions. So no complicated explanations here. More DA space directly reduce the rollup cost. What is about execution layer improvement? After we like a topic is like execution layer improvement. So what are the execution layer will be introduced and improvement in the Ethereum after this Fusaka? um, on the execution layer we can get a major boost, like a block gas target is going to 60 million default block gas, higher transaction load supported, more room for dApps under cognitions, reduce latency for the high traffic protocols, like more transaction per block we can do, better UX during the cognitions, lower latency for the protocol like a DEX gaming systems and Oracle networks. So Fusaka improves both of the data layer and the transactions layer. What is the better after Fusaka? What is the better things happen for the node operators and validator, and what are the improvement for them? This upgrade is also a huge win for the node operators. With this upgrade, they get a storage pruning, history expiration framework, faster sync times, lower bandwidth required, home staking become easier, so they get a lower bandwidth. History pruning means they can know the history and how much history they want to reduce, and that can reduce their storage also, because they don't have to download the whole blob data. They have a sampling, so that reduce their storage, fast sync times, more capacity, so they have a faster time also, faster sync, cheaper home staking. So Fusaka makes running an Ethereum node more accessible. So what is the impact on user level impact because of the Fusaka? So you think like user don't understand, or you know that user might not understand what is the peer depth, how that work and all of that things, but they will feel it. How they feel? Like L2 fees will trend cheaper over coming months. L2 is gradually drop. L2 fees is gradually drop, then they have to pay less fees for them. And then higher reliability during the peak activity, more reliability bridging, then the faster confirmations happens, cheaper bridging swap on L2s, when cheaper swaps also happens, then the stable gas pricing on L1, less gas volatility. It is the user experience that Ethereum's always wanted. Like they can experience better things, so they can also know this upgrade is fine. Then what a builder or a developer impact, like L1, L2 devs. So what is the impact for them? For builders, this is a huge larger batches they have to do and lower DA cost. So they make a large batch size of the transactions. The more predictable fees, so predictable DAs fees, how many fees they can predict. More better L2 throughput for the on-chain games, RWA, DeFi. So more reliable for the L2 infrastructures, easier L2s, architecture plannings, then more flexibilities to scale horizontal. Easier scaling planning also they can do. If you are architecting a rollups or building a system that needs consistent DA, Fusaka gives you scalability, like stability. Fusaka gives you the stability you never had before. That is the impact on builders who build on the apps and dapps on the L1 and L2. And here's the another, like for the validator and node operator benefit. Their bandwidth reduction is happen. They have a lower hardware requirement for the transactions and all the validators and all the things. Easier decentralizations, more sustainable for long-term operations. So which L2 benefit the most? All rollups benefits, but the biggest winner what? So now we know the many L2s are there. So all the rollups benefits, but the biggest winner for the biggest opportunity or biggest success for what? So high throughput ZK rollups, L2s doing larger batch proof. Like there is L2 ecosystem, data hungry chains that RWA marketplace. Data hungry chain is the RWA marketplace. Then app specific rollups like DeFi chains, gaming chains, and AI chains. Then the zero knowledge rollups, that is ZK Sync, Starknet, Scroll, Polygon ZK VM. And the optimistic rollups is Optimism, Base, Blast, Blob. So is the high throughput for the ZK rollups. L2 doing large batches proof. The gaming heavy chains, ZKVM rollups with the heavy DA usage, and general purpose like a chain of Bayes, Optimism, or Arbitrum. The ones posting the largest batches gain the biggest fee reductions. That all L2s benefit from the Fusaka. So now we want to know about what is live already. So Fusaka is already live on 3 December. Fusaka is already live. So what are the live? That all are the followings are the already activated, like a PeerDAS, Blob capacity expansion, Blob fee market fix, gas limit boost, node efficiency improvement. That all things we understand before. That all are the live already. This isn't the proposal. These all are things are live right now. Post Fusaka roadmap. What is the post Fusaka? Means the like in the future what they are planning for do in the Fusaka. So what comes after Fusaka? Further parameter tunings, optimized block pricings, state expiry research, full dark shading possible later, more light client feature, better rollups, proof tooling, like more tuning for the blob parameters, more predictable blob markets, state expiry research, full dark shading potentials, stronger and the light client features, more tooling for the proofs. Fusaka basically opens the door for the final scaling phase. Then after post Fusaka, we also see the some of the limitation or risk also we have with this upgrade, because the new upgrade, then the new risk, new limitation, what that we don't know in the future that happens also. So not everything is perfect. At the first time, not everything perfect. We how to scale, and then we see that how what are the things and what are the problems we are facing, and that we solve. So here's the Fusaka also have some limitations in sometimes. So here's what to watch. L2 must upgrade batching to full useful benefit. So L2 need to upgrade batching logic. Blob fee market might be volatile early. Blob markets may unstable at first. Sampling depends on the wide validated distributions. Infra providers need robust implementations. That infra provider must implement correctly that. Then user should expect gradual fee changes, not instant. Fee drops will be gradual, not like today is like Fusaka is introduced and the second day the fee is gradual, like fee is like decrease, not like that way. They are fee changes in the gradual way, that not instant is happened. Fusaka is powerful, but it is not magic. There always be room for improvement. There always be the new thing to improvement. So these are the some of the limitation or some of the risk they have to learn by the time by the implement. Then there is a like Fusaka, faster, cheaper, scalable Ethereum. We know about like all things about Fusaka. So to wrap everything, what is the Fusaka we can get from the Fusaka? There is a massive DA improvements, data availability, lower L2 fees happen with the Fusaka, more decentralizations happens, cleaner fee markets, like less fees happen, so cleaner and healthier fee markets, long-term sustainable scaling. Now we have to long-term sustainable scale happen because we have a data availability. Foundation for the future sharding, the scalable foundation for the next decades. We can scalable the market and the foundation. Fusaka is not the end, it's a bridge to the real sharding era. It's a new bridge in the Ethereum and the new real sharding era. So that's a deep dive we know about the Fusaka upgrade. This isn't just a technical change, it's a move Ethereum into the next era of scaling and usability. So here we are completed to our all deep dive upgrade about Fusaka. This is just a technical change. It's move Ethereum into the next era of scaling and usability. And here's our topic is finished. So goodbye everyone.